We are going to present Don't Drop Your Samples. Coherence-aware training benefits conditional diffusion. We make the observation that datasets are noisy by nature. Diffusion models are easy to condition. However, aligned datasets are rare, and usually they contain annotation noise. For example, text-to-image datasets are usually web scraped, and as you can see on the right, the captions don't always describe precisely the images. Why is it important? Because the noise in annotations makes the training harder. The datasets are usually filtered on some score that we will call the coherence score. The coherence score measures how coherent the label is with the data. For text to image, it's the clip score. For class conditional, we derive a synthetic coherence score by resampling the dataset, adding some label noise. We use the label entropy as coherence score. For semantic conditional generation, we use the softmax as a pre-trained classifier as coherence. Why do we argue that filtering can hurt the performance? Usually, when you filter, you look at both the image quality and the text coherence. If you have good image quality and coherent text, you will keep the sample. However, even if you have a nice image, you will discard it if it has a bad text. This is problematic because, as you can see, the image can contain useful information that will be lost to the models. To solve this, we propose that instead of discarding the data, we train conditioning on the coherence score. At test time, we can then prompt the model with maximum coherence and get great results. As a side contribution, we also introduce TextRin. TextRin is an architecture that is derived from the recurrent interface network architecture, but makes it work for text. The main idea is to have a cross-attention block that will condition the latence on some text tokens. One observation we made while training CAD models is that we actually discover an unconditional model for free. Indeed, if you look at the left, you can see that we prompt the model with 3 different classes: Malamute, Volcano, Cheeseburger. And as we decrease the coherence to 0, we converge to the same image. A similar observation can be seen in the embedding space, whereas as we decrease the coherence, we converge to the same embedding. This shows that our model behaves in an unconditional manner with low coherence. From this observation, we try to improve classifier-free guidance. Indeed, classifier-free guidance needs to drop out during training the conditioning with a certain probability. Here, we don't need to do this anymore. We can just prompt with high coherence to get a conditional model and with low coherence to get an unconditional model. As you can see on the bottom, we get the same properties as classifier-free guidance. We have high diversity but low fidelity when the guidance is low, and we have high fidelity but low diversity when the guidance is high. We can then look at results on text conditional models. As you can see, as we increase the coherence, our model tends to adhere more to the prompt. You can see that by high coherence scores, we get the raccoon at the window, which we do not get with lower coherence score. Similar observation can be seen with the avocado chairs that appears as the coherence score increase. Our method actually outperforms filtering for text to image. As you can see, it has a better clip versus FID trade-off than the filtering, but also than the weighted, which is weighting the loss by the coherence score, and the baseline, which is just training on the raw data. We also perform another study, and as you can see, our method outperforms all other baselines on both image quality and text coherence questions. Our method yields great qualitative samples that can capture very complicated text to yield great samples. Code and weights are made available. Thank you for listening.